With my red pen, I circled the 6EQUJ5 and wrote the word "wow!" exclamation point. It was the strongest signal I ever saw.
Have you ever wondered if we're truly alone in the universe? Back in 1977, a strange radio signal blipped onto humanity's radar, sparking wild dreams of alien contact. Dubbed the WOW signal, it was a fleeting cosmic whisper that left scientists scratching their heads for decades. Was it a hello from another world, or just the universe playing tricks?
Here's some of the signals we picked up. Are we picking up aliens? And I had to face that possibility.
In this essay, we'll unravel its history, sift through the theories, and dig into a 2025 breakthrough that might finally crack the case. Stick around. By the end, you'll see why this mystery still matters, even if the answer isn't what we expected.
6EQUJ5, tremendously strong signal. We've never seen anything like that before. Best evidence we know of coming from some other civilization.
To get why this signal had everyone buzzing, let's rewind to August 15th, 1977. Picture a quiet night in Ohio where the Big Ear radio telescope, a hulking metal beast the size of 3 football fields, was silently scanning the stars. It wasn't your average night shift for astronomer Jerry Amon. As he pored over the data printout days later, a string of characters jumped out: 6EQUJ5. It wasn't just noise. It was a signal 30 times stronger than the cosmic hum, blasting at 1420 megahertz, the frequency of hydrogen, the universe's most common element. Amon didn't hesitate. He grabbed a red pen, circled the code, and scribbled "wow" in the margin. That offhand note gave the signal its name and kicked off a scientific frenzy. Why was it so special? Well, that 1420 megahertz frequency is like a cosmic calling card. SETI folks figured if aliens were chatting, they'd use it. Plus, the signal was narrowband, sharp, and focused, not the broad static of stars or gas clouds. It lasted exactly 72 seconds, matching the time it took Big Ear's beam to sweep the sky, hinting at a fixed source out there in the void. The Big Ear wasn't some backyard toy either. Built in 1963, it was a SETI pioneer by 1977, rigged with 2 feed horns to sift out earthly interference. That night, it was aimed at Sagittarius, near the galaxy's bustling core, a stellar hotspot. When the signal hit, the team ruled out satellites, planes, even CB radios. Nothing local fit. Yet here's the kicker: they pointed Big Ear back at that spot dozens of times and nothing. Silence. The signal never returned. Word spread fast. Newspapers splashed it across headlines. Sci-fi fans ate it up. For a moment, it felt like we'd brushed against something huge. Amon stayed cautious, though. He knew a single blip wasn't proof of ET phoning home. Still, the WOW signal lodged itself in our collective imagination. What could have caused it? Was it a fluke or a clue to something bigger?
I saw the pattern 6EQUJ5. That's exactly what we expect for a strong narrowband signal.
To answer that, we've got to explore the wild guesses that came next, ideas that kept this mystery alive for nearly 50 years. So what could have sparked that cosmic shout? Scientists and dreamers alike tossed out theories like confetti after Amon's find. The big one naturally was aliens, a strong, narrow signal at 1420 megahertz. It's what SETI had been hunting for, a possible "hey, we're here" from a distant civilization. But there was a snag. If ET was calling, why'd they hang up after 72 seconds? No repeat signal ever showed up, despite years of listening. Maybe it was a one-off broadcast, or we missed the encore. Still, the silence left many unconvinced. Next up, could it be something closer to home? Maybe a satellite or a plane bounced a signal into Big Ear's ears. Trouble is, the telescope's dual horn setup was designed to catch that trickery, and 1420 megahertz is a protected frequency. No legal chatter allowed. A rogue radio nut? Possible, but the signal's power and shape didn't match typical interference. The team checked every angle and came up empty. What about nature flexing its muscles? Pulsars spit out radio waves, but they pulse like a heartbeat. Wow was a single shout. Quasars glow bright, but their signals smear across frequencies, not tight like this one. Stellar flares, too broad, supernovae, too rare and messy, nothing seemed to fit. Fast forward to 2016 when Antonio Parris threw a curveball: comets. He pointed to two icy wanderers, 266P/Christensen and P/2008 Y2/Gibbs, near Big Ear's view that night. Their hydrogen halos, he said, might have burped the signal. Cool idea, right? Except it flopped. Turns out the comets weren't quite in the beam, and their emissions wouldn't spike so sharp or strong. Back to square one. Cold War buffs had their say too. A secret spy satellite, maybe? It was the 70s. Cloak and dagger stuff was everywhere. But military signals leaned on different frequencies, and none packed Wow's punch. A glitch in Big Ear's guts. Eamon's team tested everything. The gear was solid. A hoax? Nope. The signal was raw data, not a prankster's scribble. Each theory had its fans, but none sealed the deal. The Wow signal stayed a riddle, taunting us with its one-and-done act. Was it just a cosmic tease? For decades it seemed so, until a fresh crew of stargazers took a crack at it. Their find might just tie up this loose end, and it's got everything to do with some wild space fireworks. Now, here's where the plot thickens. In 2024, a team at the Planetary Habitability Laboratory in Puerto Rico wasn't even chasing the Wow signal. They were sniffing around red dwarf stars for habitable planets. Using old Arecibo Observatory data from 2017 to 2020, Professor Abel Mendez and his crew stumbled onto something odd. Faint narrowband signals at 1420 megahertz popping up near stars like Teegarden Star. They weren't wow-level loud, but they rang a bell. Digging deeper, they traced these whispers to cold hydrogen clouds, H1 clouds to be exact, floating between the stars. These gas blobs hum faintly at 1420 megahertz all the time, but these signals were brighter than usual, though still weaker than wow. That got them thinking, could a souped-up version of this explain 1977's big hit? Their hunch was a doozy, a magnetar flare slamming into a hydrogen cloud, juicing it up to scream loud and clear. Magnetars, you ask? They're neutron stars with magnetic mojo, so wild they'd fry your phone from a galaxy away. Every so often they belch gamma rays and X-rays in flares that light up the cosmos. The team figured one of these blasts could have zapped a hydrogen cloud, sparking what's called stimulated emission. Think of it like a cosmic laser. The flare pumps the hydrogen atoms and they blast out a tight, bright radio beam at, 1,420 megahertz. The Wow signals insane strength, a perfect storm, a beefy flare, a thick cloud, and Big Ear staring right at it. Those Arecibo blips, same deal, just weaker, maybe a dimmer flare or a thinner cloud. The signals matched Wow's narrowband vibe and hydrogen frequency, but their faintness explained why we don't see Wow. Sized shouts daily, it's a rare cosmic combo. Location checks out too. Sagittarius, where Wow came from, is a stellar traffic jam near the galactic core, prime real estate for magnetars. And the one-time only thing, flares don't repeat on cue, and the odds of Big Ear catching the same alignment twice are slimmer than a razor's edge. Mendez's team didn't stop at guessing. They pored over Arecibo's logs, matching their faint signals to Wow's profile, sharp, brief, hydrogen-based. They're now begging time on bigger scopes like the Very Large Telescope in Chile to hunt for magnetars and clouds that might have lined up in '77. Peer reviews pending, but the buzz is real. If they're right, this isn't just a wow win, it's a peek at a rare space show we barely understand. Curious how this all clicks. The science behind magnetars and hydrogen clouds holds the key, and it's wilder than you'd think. Understanding magnetars and hydrogen clouds, 600 words. To wrap your head around this breakthrough, let's unpack the players. Magnetars and hydrogen clouds. Magnetars are the rock stars of the neutron star world. Leftovers from exploded giants, crushed into balls maybe 20 kilometers wide but heavier than the sun. Their claim to fame? Magnetic fields so fierce, they make Earth's look like a fridge magnet. We're talking 1 trillion times stronger, enough to mess with atoms light years away. These beasts don't sit still. Their magnetic guts twist and snap, unleashing flares of gamma rays and X-rays that can outshine a galaxy for a split second. Known ones like SGR 1806-20 have flared big enough to zap Earth's ionosphere from 50,000 light-years out. Rare, sure, but with maybe 1 million magnetars in our galaxy, they're not unicorns. Now hydrogen clouds, these are the universe's chill zones. Made of neutral hydrogen H1, they're cold, sparse gas patches hovering at -280 degrees Fahrenheit or so. They're everywhere, filling gaps between stars, and they naturally chirp at 1420 megahertz when their atoms flip a tiny energy switch. Normally it's a whisper, too faint for Big Ear to care. But here's the twist: blast one with a magnetar flare and it's showtime. That flare's energy pumps the hydrogen atoms, triggering stimulated emission. It's like shouting into a canyon and getting an echo, except the echo's a laser-sharp radio beam. In labs, we call this a maser. In space, it's a natural amplifier. If the flare's strong and the cloud's dense, that beam could hit wow levels, bright, narrow, and brief. Why so short? The flare's a flash, seconds to minutes, and once it's gone, the cloud dims fast. Why no repeat? Picture this: the magnetar, cloud, and telescope need to line up like planets in a sci-fi movie. Miss by a hair and it's a no-show. Sagittarius boosts the odds with its star-packed chaos, but it's still a cosmic dice roll. Think of it like a spotlight hitting a fog bank. The light flare makes the fog cloud glow bright, but only while it's on, and only if you're looking. Known masers like water ones in star nurseries prove this happens. A hydrogen maser at 1420 megahertz? Rarer, but not impossible. Lab tests say yes, space just needed the right stage.
This frequency, 1420 megahertz, the hydrogen line, comes from when you've zapped hydrogen, you've given it energy. This is the frequency it screams at.
So this duo, magnetar punch, hydrogen glow, could have lit up Big Ear that night. Does it hold up? Let's test it against WOW's quirks and see why it's the best fit yet. Alright, does this magnetar cloud combo really nail the WOW signal? Let's stack it up against what we know. Start with frequency. 1420 megahertz, dead on for hydrogen's natural hum. A flared-up cloud maser sings at that exact note, no tweaking needed. Next, narrow band. WOW was a tight beam, not a sloppy cosmic smear. Masers are precision artists, amplifying one frequency like a sniper's shot. Most natural sources, stars, nebulae, spray wide. This theory keeps it sharp. Intensity's the biggie. WOW was a screamer, 30 times the background raw. A beefy magnetar flare hitting a fat cloud could juice the maser to that level. Arecibo's fainter signals, 60 to 100 times weaker, hint at smaller flares or off-angle hits. Same trick, different scale. Duration, 72 seconds, locked to Big Ear's sweep. A flare's burst is quick, seconds to minutes, and the maser fades when it's done. If the cloud's glow track the beam's pass, it's a perfect match. Non-repetition's the clincher. Why no encore? Flares are cosmic tantrums, random, not scheduled. The magnetar cloud telescope trifecta aligning again is like winning the lottery twice. Arecibo's weaker blips back this up, similar but not WOW huge, suggesting rare conditions. Location fits too. Sagittarius is a galactic hotspot, more stars, more magnetars, more clouds. It's not proof, but it's no coincidence. Compare this to fast radio bursts, FRBs, magnetar-linked radio blasts. FRBs are broad, not narrow like WOW, but the flare idea's in the same family. Add a cloud maser and you've got the missing link. Past theories stumbled here. Aliens, no repeat, no dice. Comets, wrong spot, wrong strength. Satellites, frequencies off. Masers we've seen, water, hydroxyl. But a hydrogen one at 1420 megahertz. New but plausible. Labs make 'em. Space just needed the right kick. What's cool is how it ties in Arecibo's finds. Those faint echoes mimic WOW's DNA, narrow, hydrogen-based, transient. They're like baby WOWs, proving the mechanism works. If Mendez's team IDs a 1977 culprit, say a known magnetar near a mapped cloud, it's game over. This isn't just a fit, it's the first story that doesn't trip over itself. No loose ends, no but what ifs. So what's it mean for the bigger picture, like, say, the hunt for E.T.? If this theory holds, what's the ripple effect for SETI? It's a wake-up call for starters. WOW was the gold standard for an alien ping, strong, narrow, weird. Now it might be a natural fluke. That doesn't kill the dream, it sharpens the game. Big lesson, nature can fake techno-signatures. A matter-lit cloud mimicked what we'd expect from ET, focused, loud, hydrogen-flavored. SETI's got to up its filter game, ruling out these cosmic imposters. How? More follow-ups. Catch a signal, then scour the spot for flares or clouds. One-offs won't cut it anymore. Arecibo's coup shows old data's gold. Dust off the archives, tweak the lens, and bam, new clues pop. Future searchers can lean on this, cross-checking signals against flare logs or cloud maps. It's detective work, not just wishful listening. Tech's the ace here. Arecibo's gone, but the square-kilometer array's coming, sensitive enough to spot faint mesas or pinpoint flare sources. Pair that with gamma-ray scopes hunting magnetars, and we've got a playbook to test this theory and beyond. It's not all caution, though. Studying these Marses could flip the script. Maybe they're common and we've missed them. That refines SETI's ear, tuning out noise to hear the real deal. Plus, it's a science win, a new type of cosmic flare show to chase. Does this dent the ET hunt? Nah, the universe is a haystack. One solved needle doesn't empty it. It just means we're smarter sifters. The thrill's still there, every blip's a chance, and the next wow could be the one. Speaking of thrills, this signal's story doesn't end here. It's left a mark that's still echoing. Even solved the wow, signal's got staying power. For 48 years, it was our what-if moment, a spark that lit up science and daydreams alike.
Here's some of the signals we picked up. That are we picking up aliens? And I had to face that possibility.
It dragged radio astronomy into the spotlight, fueled SETI's fire, and gave us a puzzle that wouldn't quit. Think about it. One scribbled, wow, birthed decades of research. It pushed Big Ear's successors, like the Allen Telescope Array, to scan smarter. It nudged SETI from fringe to legit, inspiring pros and amateurs to tune in. That's not small potatoes, it's a legacy of curiosity. Pop culture grabbed it too. X-Files episodes, Contact's plot twist, even video games. Wow was the go-to maybe signal. It turned a data glitch into a campfire tale, making us all stargazers. Ever heard someone say wow at a sky full of stars? That's partly Aman's doing. The human side shines here. Aman's red pen wasn't just science, it was wonder, raw and real. It's a reminder that behind the graphs, people chase the unknown because it's electrifying. This resolution, it's not a letdown. It's a nod to that grit. Science chipping away till the truth cracks open. And what a truth. If it's a maser, we've bagged a cosmic first, a hydrogen flare show tied to a 1977 blip. That's not closure, it's a launch pad. New questions pop up. How many masers are out there? What else can magnetas do? The wow. Signal's done its job. It's handed us a torch. It's still a rallying cry, too, solved or not. It whispers, keep looking. The sky's too big, too wild to stop now. That's the real payoff. Mystery or answer, it's the chase that shapes us.